traveling a bit, so in a hotel giving this, so hopefully all is fine and you can hear me. Um, also, I don't have my second screen with me, so we'll see how it goes between all the screens and some of the questions we need to do tonight. Okay, so yesterday we looked at the first part of the previous exam, so it was May 2016 exam, and basically we covered up until around study unit 6, 7, and then tonight basically going to continue with it. So nearly rounding it off. So tonight we will cover some of your hypothesis. We will cover I think confidence intervals, chi-square, and your regression questions. Okay, so and then we can after that talk about the exam. Okay, so question 15 basically continued from question 17. Question 16 continued from question 15. And also you can see there's some information that I just copied from question 15. In your exam, if there is, remember this was pre-COVID, so this was paper-based, but if you need data or information from a previous question, it will be given to you again in the next question. So they can't ask you in question 15 to do something, and then question 16 they don't give you the information. So for you guys, it will, if there's data or anything that's needed for the next question, it will be given in the question again. Okay, so here they ask us to use the previous information, and we need to calculate the critical value. Okay, so and maybe on the chat you guys can also say, but how do we calculate the critical value? So if this was in your exam, what would you have done to calculate that critical value? Okay. So let me ask it a bit differently. Would you work out a Z, or will you use the tables? Okay, so, and I think that is the most important table. Okay, so critical value, we use the, and now I can see my house is not really reacting very well. So you're going to use a Z table. Okay, so you actually don't need to have Excel. Use a Z table. We know with proportion, we're working with always a Z. The only time that we can work with a T is when we work with your mean, and when we know that the population is unknown. Okay, so when we know that the standard deviation is unknown, that's when we work with a T. So need to work with a Z table. But if we test 5% significance, so let's, and since it is open book, you are allowed to use my notes as well. And I know in that notes, I have added that, where was that table? I think in study unit 8. I just want to, and then I will share that quickly on the screen. Okay, so let me quickly, now I just need to move between screens, so we will get it now. Okay, so remember this table, I have jotted it down on my summary notes as well. So if you have not, if you don't have a summary notes, I'll share it on the WhatsApp group again. But look at two tail. Normally, the 95% is 1,96, and for one tail is 1,645. Okay, so let's go back to the question. We are looking at the 5%, so it can be 1,96, or it is 1,645. Okay, so let's see, is this a one or two tail? If it's only bigger, so that is bigger, and that is equal to, so what does that show me? It showed me we're working with a one tail. One tail means the critical value is 1,645, or critical value 1,645. Okay, so we didn't, if we needed to work out our t-stat or test statistic, then we would have gone the whole way of Z is equal to, and in this case, it would have been proportion. So we would have done this whole equation, but we want to use the critical value, so it's not needed. So we can actually just go to the table. So just be careful and just remember the difference between critical value and if we need to work out the test statistic. So you can nearly use that small table, write it down somewhere and have it with you, so that you nearly know when you guys are working with 90, 95, and 99%. That's the things that you need to know. Okay, so then we have, okay, let's quickly work it out. Okay, so let's quickly, that is what, divided by n into square root of it. Okay, so we've got, let me quickly use my calculator. So we've got the top part is, so we've got the sample proportion as 0.45. We can say 0.45 minus 0.4, which is going to be 0.05. And then at the bottom where we divide by the square root, so we say square root. And some of your calculators are better that can do this in all-in-ones if you have all the brackets and things like that. Mine doesn't. So I'm still doing it a bit old school. But hopefully we'll get to the same answer. And hopefully that answer is not part of the answer set, so that, okay, so let's just quickly, if somebody else can also check. So the top part, I got the 0.05. Then the bottom part, I got 0.4 times 0.6 divided by 49. And if I take the square root of that, I get 0.069. And then if I divide the two into one another, I get 0.71. So I don't know if somebody else also got that. Okay, cool. So that would be your test statistic, and luckily there wasn't an option for that. So luckily there wasn't. I think, yeah, this time around, most likely there will be. Because one can see again pre-COVID some of the ways that they given answers differs from what we've seen post-COVID and for online environment. So they probably would have, and that one would have been probably closer to the 7.1. So it might be that in your exam, that one is actually 0.71, and not 0.76 or something like that. Okay, but if you follow this process, you will get 0.71. Okay, cool. Okay, next one. Let's see what we're asking here. So, testing the hypothesis. Mean is 50. Mean is not 50. Okay, so before we even go, one or two tail. And I wonder if that will make a difference. Probably not. So while you're thinking one and two tail, and nearly, now we need to work out the test statistics. So they would ask, and how they would ask it is, this is now a nice way how they will frame it. So they give you information, they ask you to work out the value of a standardized test statistic. Okay, so for this one, we'll use the Z. The Z is the X minus the mean divided by, sorry, I'm really struggling tonight with my PC. Okay, so this is your formula that you also would have in your study guide. We've done it in study unit 7. We're just applying it again in study. Oh, you would have had it in study unit 6 and 7. The 1 divided by n will be in 7. We're just applying it now with hypothesis. So we've got the x as 53. We've got the mean as 50. So at the top, we're going to have 3. So when I look at options, option 1 is not, because it's going to be positive. What might then be, because there was negative 2.6, I'm already nearly thinking the negative 2.8, that the positive 2.8 might be the one that we're looking for, but let's see. So then we need to divide by standard deviation, which is 10 divided by, okay, that is, just check my formula. I think I've done it wrong. It should be the standard deviation divided by square root of n, and not whole thing. So standard deviation divided by square root of 64, which gives us 1.25. So 3 divided by 1.25 gives us 2.4. Oops. Okay, wait. Let's just quickly see if it's okay. Already there, I've made a mistake. It must be 5.5. Sure. So that's 5.5. If it was not 5.5, 3.5. Okay, let's rephrase that. Okay. X minus the mean divided by standard deviation divided by the square root of n. So 53.5 minus 50, that would give you at the top 3.5. At the bottom, standard deviation is 10. Square root of 64 is 8. So we divide basically by 1.25. And then the final answer is 2.8. Okay, so that is option 4. I just want to see, so if you swapped those two around, if you said 50 minus 53.5, you would have gotten option 1. Oof. And the others don't have the faintest idea how we would get to that. They don't give us the confidence interval or significance level, so it can't be that we make a mistake with working out the critical value, because they don't give us the information for critical value. It might be a next question, but at this point we can't make the mistake to work out a critical value. Okay, so here's straight, they ask us to work out the standard test statistic. So we use the formulas and then calculate it. Okay, so now they're doing it a bit differently. So they tell us, this Z that we calculated which was 2.8. We now need to work out what is the p-value. Let's just look at, again, okay, and this is where two-tail becomes important, because when we work out that answer, remember two-tail, so here's a piece still here as well, which exactly the same size. So if we get this proportion, we need to multiply by 2 to get the p-value. Okay, so let's go to our Z table. I will share it again now. Okay, Z table is there, 2.8. So let's, and it was on the dot 2.8. So 0.9974. So 0.9974. 9974, see where it is, which is not what we're looking for. So this must be 1 minus that. So let's do that. So 0 minus that, it gives us 0.0026. And then we need to multiply it by 2, so 0.0052, which is option 2. Okay, so very easily one could have made the mistake by going for the 0.9974, because that is what we see in the table. But remember that 0.9 is this whole area, including that portion. So we need to find out what is that plus that, because that's the p-value. So the 0.0026, which was the answer, but we need to multiply by 2. Are you guys happy with that? Is that clear on your side? I think, again, that's why it's important. I remember I asked nearly on the beginning of a question, 1 or 2 tail. I didn't realize it would then come in later, but very important nearly to see that 1 or 2 tail, how it pans out. And that's normally why they give you the information, so that you can work it out in the second one. Okay. And that's why I hope there isn't really questions that follows from one another, because if you had this wrong, you would have a next one wrong as well. So hopefully there isn't a lot of these, like in this exam, that followed onto one another. And maybe you guys can say how your mock exam was, but we can talk about that afterwards as well. But I think they've moved away a bit from questions following from one to the other. They might still use the same data, but they nearly have a different question on the same set of data. Okay, so let's look at question 19. Now we're going into confidence intervals. The first one that we're looking at is a confidence interval of proportions. We look at 80 divided by 100, so our proportion is 0.8. Then we normally say plus minus 95%. Remember, confidence interval always two-tail, 95%, 1.96. And then because it is proportions, we multiply it by we multiply by the standard error. So I think that's nearly important. That doesn't matter if you do the normal distribution, or if we do proportion, or sorry, if we do mean or proportion, remember we basically multiply by the standard error. Okay, so this one, again, that is 0.8, so I'm gonna quickly try it on my calculator again. So 0.8 times 0.2 is equal to 0.16. 0.16 divided by, just want to get divided by 100 gives us 0.016. And then we need to square root that still, so it will make it bigger at least. The square root of that gives us 0.04. So we're going to have 0.8 plus minus 1.96 times 0.4. Okay, 0.04, sorry. Let's just put in 0.04. Okay, so basically we can look at this again. So we've got, and you can just check for me, I've got 0.8 plus minus 0.0784. So I will have on the top side 0.8784. And on the bottom side, I will have 0.7216. So option 1 will be my answer. Okay, so let's just check for other ones. Might be, sure, it's very small changes. So it can just be by using a different set value, but those numbers can change. Okay. So this one is nearly straightforward. There's no catch in it. You just need to know that with 95% confidence interval, you're using 1.96. Again, you will not get a 94 or 96 or anything like that. You will get 90, 95, 99%. So there will be not any of the others. And then what you will get, and most likely the next question will now be one where we will use or Z or T, because you normally get two confidence interval interval questions. Okay, so let's see. So it is definitely we're working with mean that we're going to work out. So it is or a Z or a T. Your stats instructor wants you to determine a confidence interval estimate for the mean test score. Past experience indicate that test scores are normally distributed with a sample mean of 160 and a population standard deviation of 45. A 95% confidence interval estimate if your group has 36 students. Okay, so is it a Z or is it a T? And again, you can just on the chat say what you think it is. Okay, what would you have used, a Z or T? The population standard deviation is known, so we use a Z. Z of 95 is 1,96. Okay, so important, they tell us the population standard deviation. So we then will multiply that by the standard error, which is the 45 divided by n. They tell us n is 36. So that we're going to square root, so it's going to be 6 in the end. But let's quickly work that out. So we basically have 45 divided by the square root of 6. That we are going to multiply by 1,96 because our Z was the 95%. So I got it as 160 plus minus 14.7. So at the top we will have 174.7. So let's quickly see 174.7. No. 174.7, 0.4. Okay, but remember we will also need to have a bottom one. The top one is that, bottom one, we will subtract 14.7. So we will have 145.3. Okay. So that is option 1. Okay. Any questions around this? So the important one that we needed to identify was that the population standard deviation was given, and that was 45, and then you use that in your equation. Okay, so if it was unknown, that means we would have needed to calculate the t value. Let's quickly see if it is. Okay, so this was again. Okay, so let me quickly show you. So if we needed to do this, t value would have been n minus 1, 95%. So We will work with alpha. The alpha divided by 2, so we will have a t of 35 and alpha divided by 2, so it is 0.05 divided by 2 is 0.025. So that would have been what we would have been looking for. So then we needed to go to T 35 0.025. So we would have had 0.03. So 2.03. So if we worked with T, it would have been a bit different. I hope there wasn't an option for that. No, it doesn't seem like it, because it would have been something different. It would have been 15, and nowhere we've had a 75, so that's fine. Okay, but if it was unknown, that is what we would have done. Okay, so just that you have that as well. Okay, then strangely enough, I had another confidence interval for proportion. Again, you will not get two of them. You will only get one. So sorry, I just quickly want to mute my hotel room's phone is buzzing. Let me quickly just answer. Sorry. Okay, so in this one, again, as in question 19, we will need to follow the same process. Look at proportion. There's a 95, so we know that the Z is 1.96. And then we will also again need to work with the standard error. Okay, and what is the proportion is 410. So 410 divided by 1,000 is 0.41. So that would have been our formula that we work with. Okay, 0.41 will be in the middle, so it can't be 0.4404 because it should always be smaller than that. Yeah, that might be, okay, all the others might be. So let's quickly check if we can solve this. So it is 0.41 times 0.59 divided by 1,000 and square root of that. So let's quickly check. 0.41 times 0.59. I get as 0.2419. I divide that by 1,000. I get 0.000242. If I take the square root of that, I get 0.015553. And if I multiply that by 1.96, I get that we will work with 0.03. Let's just see how many decimals do I need. I need 4 decimals, so 0.0305. Okay, so it's going to be 0.41 plus and minus 0.0305. So 0.4405 will be the top one. Okay, so not that, not that, not that. And then the bottom one will be 0.3795, which is option 1. Okay, in your exam, I don't think you will get two of confidence intervals with proportion. They would rather ask you in one where the population standard deviation is unknown. Okay, so let's go into question 22. Here they ask us, and they give us the chi-square. In the chi-square, you can see they give us some data, and then they ask some questions around it. So at the moment, we don't nearly need to work out anything. We can work with the information and just see what else is needed. Okay, so find the one which is incorrect. Okay, so I want to go to degrees of freedom first. So there is 4 rows, 4 columns, 2 rows. So it's going to be 4 minus 1 is 3, 2 minus 1 is 1, so 3 times 1 is 1. It's correct. We're looking for the incorrect one. Okay. Second one that I will look for is to say, but look at your null hypothesis, and if I also give you your alternative. So null hypothesis for chi-square is always looking at independence. So if that is independent, your alternative will be dependent, or the other words that I like to use is non-independent. So just be on the lookout for those wordings, but that is also correct. Okay, so then the next one that we're going to look at is to work out the expected value. So these are all observed values. So the expected value is when, so let's look at youth and girls. So it's the sum of youth, which is 58, times the sum of girls. Okay, so that we now quickly need to tally up. So that is 18 plus 12 is 50, 20, 78. Cool, thank you very much. And that divided, they told us, was 200. Okay, so 58 times 78 divided by 200. What does that give us? Okay, so I got 14.82, which is also correct. And then the last one, the chi-square curve is symmetrical. Okay, so let's quickly look at it. So remember, it is in chapter 10. I don't think they show it to us in chapter 10 really, but they do show it to us in the graph. Okay, and there we can see it is definitely not symmetrical. So chi-square curve is symmetrical is the wrong one. Okay, only the normal curve is symmetrical. So chi-square, oh, sorry, I didn't now share the screen with you. Let me quickly share the screen so that one can just clearly see it in the document. So under chapter 10, where we have the table of chi-square, you can there clearly see with this that the distribution is not symmetrical. Okay, if it needed to be symmetrical, it would have been a normal distribution, and then the bump would have been nearly in the middle. Here the bump is to the left. Okay, so definitely not symmetrical. Okay, so that was that chi-square question. Then unfortunately, the next one is we now need to work out the t-stat. Okay, so this is where I would now have used Excel, because this, and also remember when this was, that question comes from a previous exam that was paper based, so students also didn't have Excel at that stage. But yeah, so but I still, if you have if you nearly have a means, why not allowed to use it? But yeah, we've been overruled on that one, so not able to use Excel. So I'm just going to show you quickly what I would have done, because again, it is very difficult to do this, or not difficult, but time consuming. So let me quickly share with you the Excel that I have opened. And let's just make it a bit bigger. Okay, so you can see I now have it that is the original data. There's your totals. The totals wasn't in there. So I so here is now the numbers. So let's quickly just see this. Okay, didn't work out that easily. Don't now want to go and fix numbers. I'll rather just move the squares for now. Okay, so what we've now done is all the expected values. So, and then remember your formula is, and let's put it in here. Your formula is that you take the observed minus the expected, and you square root. Let's quickly check. It is again on the intro to study unit 10 in that summary page nearly. Square root and then divide by the expected. So for you guys to have done this now in the exam, you needed to make 1, 2, 3, 4, 5, 6, 7, 8 expected values. So what I have seen, at least in the last exam for 1610, when they needed to do this, then at least it was that there was the expected table was given, so that one can then do this part nearly in yellow, only that you didn't also still needed to work out the expected. See, and then that will just be a sum of that, which is now 6,89. I will share the spreadsheet in any case with you. And then the 6,89 was option 3. Okay. In the exam, if you now don't use Excel, this would have taken you a bit longer than usual. What will happen most likely also in the exam, if you get something like this, it will be more likely a 2 by 2, and then they will also give you your expected values, that you only need to work out the difference between that. Okay, hopefully it's not like that. And hopefully they only give you one that you need to work this out, and one where they ask you nearly to look for the critical value using the table. Okay, let's go into the last two. Okay, so they're giving you two variables, profit Y and research and development expenditure Y. Interesting why both is Y. It should be X and Y. So let's just assume that is X and that's Y. Because if we add things, okay, see, so again, if something, I'm now not in contact with a lecturer at all, but definitely here is a big, this would have been a big issue, because if you look at the sums, this is X and this is Y. Okay, so automatically something like this will be a big issue, because it doesn't matter what you use, it's not going to work. This you can, so now that we know that's X and that's Y, you can use your financial calculators to calculate that, or Sharp, HP, or Scientific. So that is definitely not a problem, because that will give you your answer. But what I'm quickly just going to do is also just show you how I would have done it in Excel. I don't have my financial calculator with me, so there is no ways I would be able to do that on my cell phone calculator. So I'm showing you, but now what I'm going to do is, just as they said, so that's Y and that is X. I'm going to put in the numbers and then I will make it bigger. So you guys will or have a formula for R square. So they also give you all the other information in here um, to be able to work out R square. So if you look at the information that they give you, everything in here you can use in the formula as well. But obviously, it's easier to use the Excel functions. Um, just feels like my... Okay, so put that one in. That one in. Okay, so coefficient of determination, remember that is R square. Coefficient of correlation, what we calculated is R. Okay, so we still need to say that to the power of 2. So very important. And you will see, wow. Okay, so this is totally wrong. Coefficient of correlation is R. Coefficient of determination is R square. So nothing really in this one is adding up. Sure. Okay, so it just shows you, and it doesn't matter really which data is where, it will stay the same. So here definitely lots of issues because none of them are. So that is coefficient of correlation, that's R, but there isn't a R square. So sure. Okay, so this one I'm nearly going to, let's see, I just want to make sure I draw and draw. And really, you guys must not, because there's so many errors in this question. If you if you feel that there's an error in one of your questions, I know I now don't have contact with your lecturer, but then send an email to the lecturer. Just that because this hopefully will not happen. But there are so many mistakes in this question. And yeah, it was years ago, but it's not nice to have so many errors. Because now again, we're working with those information, and hopefully we can, yeah, but yeah, so we're working with that information, but we know there's errors in it. So let's quickly, I'm just, I will quickly go to the next question now. I just want to go work out the slope. And I just want to quickly, so they want us to put in the y's in slope first. Okay, so they say the slope is 2,4. Okay, 2,41. Okay, so let me share you the second question on this data. Okay, so that was the previous one, but I'm just like, guess when I share it also with you guys, just ignore it because there's just too many errors. But now we've seen with the slope that we've calculated was 2.4. So already, if I look at these options, now suddenly that is, and which is incorrect. So the slope is incorrect. If that is the slope, but if it's 2.4, that one is also incorrect. So everything is just totally wrong in this whole question. So obviously with that, the data was, from the beginning, the data was wrong. So basically 2 questions in here is not doable. Let's just, if I didn't have question 24, so let me quickly just show you what I would have done with something like this. So if I get a question like question 25, so in here, they tell me, so that's your y cutoff, that's your slope. So now I already see if, and one must be incorrect. So now I already see I can, slope is that, y cutoff is that. So if those two are wrong, for this to be right, it can't be. So only one can be incorrect. Okay, so if slope is right, this one is wrong. So if slope, that intercept is right, this one is wrong. So by actually not having the data or even knowing how it should look like, I could have identified one to be wrong just because they give us the intercept and the slope. Okay, because if my intercept was wrong in this instance, you can see my slope is also wrong. But unfortunately for both of these questions, nearly one can see that the data, original data is wrong, which is not great. So in this exam, if somebody didn't see it, 2 questions was basically totally wrong. Okay, but it does give you a good indication of what they might ask you. So they give you the data, they give you the input variables so that you can still use your calculator. So you can use your calculator with the X and Y functions to get the data. On my HP, I can do that. Then if you don't have the calculator or HP or Sharp or Scientific, and you want to use the formula, all of this you can put into the formula to calculate it as well. Okay, and then the same with question 25. If your data was correct, you could, again, on your scientific or your 2 financial calculators on both, you can work out what your slope would be and what your y-intercept will be. See, and if you look at these two, the mean, if I look at this, the mean of x, see, so divided by 1, 2, 3, 4, 5, 6, 32 divided by 6 is about what, 5? So that might be, and then x, so that divided by 6, so about just less than 50. So that would have probably been also correct. The relationship is very strong with your R value that is so high. The relationship is also very strong. But again, the data doesn't really speak to one another. Okay, I'm gonna share with you the Excel that I've now used in tonight's session here on my screen. So I will just share that. Exam prep 2. Then what I will also share with you guys again is this presentation. Then what I'm also going to share is when I've loaded the recording, I will just add that to YouTube as well. Anything else that you guys still really need? So let's quickly, what else do we need to cover? Any questions on your side? Okay, anyone? You guys can mute. I'm gonna quickly. How to use current Excel with regression. Okay, so let me quickly. So the Excel that I created, that one, that I can just quickly. So let me quickly go to. Just want to find that one. Yeah, just give me a minute or two to just get to it. Okay. I'm gonna. Okay, so it's this one. Okay, so what you would see in this table is, so for this data set, where the X and Y was, we calculated the X square, the Y square, the X and Y. So all of those that you can nearly get the different summations. I just want to see if we, in the end, okay, so we didn't in the end, but all of those summations, that's nearly, you can see here. Sorry, but we used the correlation coefficient and all those formulas. So what we've done is to say, okay, there's your data, here's the X square, Y square, X times Y, X minus the mean, Y minus the mean, and then also the X minus mean, Y minus mean, the, the sum of that, to the power of 2, the sum of that, also the y to the power of 2, the sum of that, so that we can use it in this formula. But what I've also created, so is with just looking at your Excel formula of correlation, so which is for Coral, which looks at those two data sets. So here, using nearly the formulas, so what you could do is also put in, if they tell you the sum of xy minus, so if I give that to you, you can put it in here as well. You can actually just type it in and it will automatically. So if I knew, and I don't want to now change anything to here, but if I tell me it's 400 and you put in 400, everything will change. So what we've done with this is your this is your data input fields. Actually, just that part is your data input field. All of these you don't really need to worry about, because that's just for all the different formulas that's nearly possible that we've worked it out. But here you can see, so the sum of xy, it was that number. So we just transferred it. So these are the things that you actually need to nearly look at. So again, to use the formula of a slope, so let's quickly make it a bit bigger. So here's that massive formula to work out the slope. Out of that table above, we could get all of these numbers. So here's the slope calculation from there, but this is also the slope calculation using Excel's internal calculator. The same with if we needed to work out the intercept. Again, there's your mean values. It is all in this part. So your mean values comes out of this. It's all in the formulas at the top. We just copied it from up there, and then again with the formula of B0, to work out your intercept, there's also exactly the number that would have been if we used the internal Excel calculator. And every time you can see it matches up. Okay, so that's nearly also, if you change this data, just remember to check if this still matches up. If there's less data in your spreadsheet or in your the rest you delete. If there's more, what you do, somewhere in the middle, you insert data fields to put it in, just so that all the formulas still work with it. Don't insert it at the bottom, because then most likely it will not be counted in the formulas. Okay, so does that help a bit? Is that what you nearly wanted to see out of this? Okay, cool. There is lots of other stuff that is not needed. So nearly you can hide a lot of those things as well, because there's really a lot of info in those spreadsheets that you really don't need to look at. Yeah. Okay, anything else? I am stopping recording so that we can